Hello everyone, in this tutorial we are talking to tracking ID IMDb score trends over the years with Spark and Seaborn. Here is the goal. The goal is creating a line plot that shows how to average IMDb scores for movies, TV shows have changed over time. First step is start by click the code. It's reading data from CSV in Spark. From the previous lectures, this brief code is to read the CSV file into the Spark data frames DF with the format option load. So second step, extract column names from the first row. From the first row of the data frames, it is what it does: retrieves the first row, which contains the real column headers, and then convert each cell to a string. It is why, because your CSV doesn't include the headers, so the first row is actually the head information. We assign these are columns names. 3 is remove the header row from data. The filtering out the original header row so only data remains is what it does. This is why to prevent the header row from being treated as data. 4 steps: assign actual column names with this Python code, remaining the columns of the data frame with the header we extracted earlier. Why using that one? It is to access columns by meaningful names like release year and IMDb score. Step 5 is calculate average IMDb score per year using Spark. This code is started by the groups data by release year, this one, and then computes the average IMDb score for each year. This is why using it is to understand the trends over the year. These are the scores improving, declining, or stable. Step 6, convert Spark data frame to pandas for plotting. Here is the converting the Spark results to a pandas data frames with a PDF. This is what it does, and while using that one, it is Seaborn's and Matplot library work more seamlessly with pandas data frames. Step 7, handle real is underscore year for better plotting. For better plotting, we're using the converting release to numeric and setting invalid data to none. It's not null, and then convert it to string for plotting, truncating to 10 characters if any special format is present. This is option if you need it, and this is why using and ensuring the access level are consistent and correctly formatted, especially if some entries have the extra text. Step 8, plot the trend using Seaborn line plot. We're going to import the Seaborn and Matplot library .pyplot, and the figure size is 20 and 6, and line plot we're using the line plot in Seaborn, right? Here it is. We're going to Seaborn where the line plot using by data PDF after we handle all release year for better plotting and to convert Spark data frame to pandas. Before that, we did the calculate average and then remove the header row, fourth row. We're using the plot title X or Y axis label and X to show every other years the rotate labels for clarity. So I'm going to click this from this cell. Okay, here is this. This graphic is trending of average IMDb scores over these years. Based on the step and visualization you described it, here is how our analysts fit into different categories. What kind of analyst are you doing? This is exploratory data analyst, EDA, and then data visualization, structured data analyst. We are examining data distribution. This line plot is a key visualizations technique, and you are working with the structures top data loaded into Spark and Pandas. Correct? Here's an analyst suitable for beginners based on the provided line plot. What does this chart show is the chart display how the average IMDb score of movies and show have changed over different release year. From the 1987 to 2003, 2008, 2005, 2020. So here is the key observations. The early year near 1980, the average scores are very high, often above 2000 or more. Now this likely indicates data issues or missing data and mistakenly inflates the score because actually IMDb scores are between 1 or 10. Most recent year around 210 and 220, we're talking the average IMDb scores are very low, close to 0, indicating the level or data may be incorrect or represent some other metric. So note about data is this is a plus shows extremes value, which strongly suggests that the release year or IMDb score data is corrupted, not properly cleaned. The score shouldn't be as high as the thousands or as low as near 0 unless there are data formatting or processing issue. What can we learn? Data quality check. In terms of we're talking the data quality check, when analyze data, make sure the IMDb scores value are in the expected range 0 to 10. The strange spike and dropped it indicate a problem with data entry or processing. Here's the importance of data cleaning before drawing the conclusions. Always verify the data ranges and clean any anomaly. So visualization's caution is these visualizations are powerful but can be misleading if data is incorrect or unpressed. This is the impractical business analyst always to check your data range before plot and model. Look out for outlier or spikes that doesn't make sense. They might need correcting or removing. Good data quality is essential of accurate insights and decision making. Here is a summary for you. This plot shows a strange trend that highlights the importance of data validations. Visuals can tell us about the data issues if you know what it looks for. Always verify data correctness to avoid misleading readers. Would you like to help on how to clean this data or refine the visualization? Absolutely. Here's a step-by-step guide on how to clean your data and refine your visualizations for meaningful insights. Do you know how to handle this? I'm going to tell you in the next video.